but I'm mostly concerned on us making sure we get these first 4 points, right? That part C is going to be a little bit of a wild card sort of problem, and we've been over some of it. If you were really good at these 4 things, you should probably be able to do those problems, but my main concern is we get the first 4 points, right? Those are the ones that we should be automatic on, and then the others are a bonus if we get them. Yes? This will be calculator inactive. So 3 and 4 are both calculator inactive. So you must know log properties, exponent properties, trig identities, unit circle, how to convert from log to exponential, which we just used inverses, and inverse trig notation. All of this is posted on Canvas. So if you want to go, I'm not going to give you time to write it down right now, but if you want to go look at this, all of this is posted on Canvas. It's a nice little summary of things. Your log properties are here, exponent properties. The trig identities, we just memorized all those and took a quiz on them, so they're all there. For that, we got to know all of those things, and they will be applied in this 4th one. So, let's do a problem. Okay, what they're going to do, this part will have 5 different functions. This only has 4 because it does not have part C in it. We're just focusing on the basics here. It will be a mixture of logs, exponentials, inverse trig, and regular trig. Right? So and a couple of them are going to be asking you to solve, and a couple of them are going to ask you to rewrite or simplify. So if we look at this first one, okay, it says they give us G and H. Solve G of X equals 7. First of all, make sure you're picking the right function. Right? So G of X equals 7 for values of X in the domain of G. So G of X is natural log of 3X plus 5. We are just going to set that equal to 7. Okay. Then we're trying to solve for the X. We're trying to get that X right there by itself. What is the first thing that we will do? What? We got to get rid of that natural log. How do we do it? E to the power, right? Because the base on that natural log is E. So we'll do E to the power, and that'll just give us 3X plus 5. And we're just going to have to write this as E to the 7th because this is calculator inactive, so we can't do anything with that. And now we really just have like a pretty simple equation because E to the 7th is just a number, right? But we're just going to have to leave it in there. So we're just going to subtract 5. So we got 3X equals E to the 7th minus 5. And then we're going to divide by 3. So X is going to equal E to the 7th minus 5 over 3. And you really can't simplify anything here, so you just stop. That's it. Okay, it's going to be something like this. It's going to be a pretty basic to medium level log equation, right, for that. Okay, same for part 2. We are just going to take inverse cosine of 4x and set it equal to 2 pi over 3. So we've got inverse cosine of, what was it, 4x equals, the questions are going to be on the computer, and you will write your answer on an answer sheet on paper. Our mock exam, I will do that way. I haven't done them that way just because it's a pain to do it, because putting things into AP Classroom is annoying. But I will, for the mock exam, the one you guys will do on your own, I'm going to print off the what your answer sheet will look like, so that you've got some examples. So the questions up here, they'll be on the computer screen, and then you'll just have an answer sheet with boxes that you fill in. The boxes will be much bigger than this here, but just trying to conserve paper a little bit. So Same thing here. When you're solving an equation, you're trying to get the x by itself. That means you got to get rid of inverse cosine. How do we get rid of inverse cosine? Regular cosine. So we have 4x equals cosine of 2 pi over 3. And cosine of 2 pi over 3, we can find. It is a unit circle value. Right? 2 pi over 3 is right here. Coordinates are -1/2 square root of 3 over 2. What is cosine of 2 pi over 3? -1/2. So we just have 4x equals -1/2. We must divide both sides by 4 here. This was something I was seeing a lot of us mess up on that last test. Not necessarily, well, actually on ones like this too. So if you divide by 4 right here, you are dividing by 4 over 1. If you're dividing fractions, you need to make them both a fraction. Be careful. Some of you are flipping things when you're just multiplying. If you're not dividing, you don't have to flip. You just multiply straight across. But if you're dividing, make them both a fraction. So x is going to equal -1/2 times 1 over 4. And you will get x equals -1/8. Okay, everybody good there? Another option right there, so you don't have to do dividing fractions, is to multiply by 1/4. It's the same as dividing by 4, and then you just get -1/2 times 1/4 right away. Okay, part B. Now, A and B can be switched. Sometimes you're simplifying in A and you're solving in B. Sometimes it's the way that we see it now. But in general, you're going to have one section where you're solving an equation, and you'll have another section where you're rewriting here. So for B, we are supposed to rewrite this only using cosine. It does say a fraction involving powers of cosine and no other trig functions. So we've got secant x cotangent squared x. So j of x equals secant x cotangent squared x. All right, what strategy do you guys want to try for this one? That's exactly what I would do. Secant is going to be 1 over cosine x, and then cotangent is going to be cosine squared x over sine squared x. Okay? Ideas now. Okay? I would probably cancel a cosine first, and then I would do exactly what you're suggesting. Although the order doesn't necessarily matter there, Evan. Like you could go ahead and change that to a 1 minus cosine. But you do have to simplify. Everything's multiplied here, right? So I can cancel this cosine with one of the cosines right here. So now I have cosine x over sine squared x, and like Evan suggested, I'm going to turn sine squared x into 1 minus cosine squared x. And let's see what they were asking us for. A fraction, we got a fraction, involving powers of cosine. I've got cosine, one of them's to a power, and no other trig functions. We're good here. You cannot simplify any further. You cannot cancel a cosine here with a cosine squared. The reason is because of that negative right there, that minus. Over here, you could cancel because everything was multiplied. What was separating the stuff that you canceled from the stuff that was left was a multiplication sign. Here, if you do it, it's a minus sign that's separating what you're canceling from what's left. So, so you can't cancel. You're just going to leave it like this. Okay, if I left you to your own devices, I feel like this last one would be what we would do the worst with, because it's been a little while and we weren't really great with it whenever we started. Just screenshot this right here. So we got this big long equation right here that I'm going to screenshot and put right here so that I don't have to rewrite it. There. All right, so they are asking us to rewrite this as an expression in the form 3 to the ax plus b. So if we need this to be 3 to a power, like 3 to something, we need everything to have a base of 3, right? So the first thing I need to do here is I need to write 9 as 3 to a power. 9 is 3 squared, right? So that's going to be 3 squared to the 2x plus 3 power. I don't really need to do anything here. I got 3x plus 2. And then in the bottom, I need to write that as 3 to a power. How do I write square root of 3 as 3 to a power? Not negative 1. One half, right? Because for roots, like if I have the b root of x to the a power, that is going to be x to the a divided by b. So right here, we've got the square root, it's a 2 on the outside, of 3 to the first power. So that is going to be 3 to the 1 over 2. So roots are fractional powers. Okay, what do I have to do when I'm raising a power up to another power? We multiply, right? Just like if I had x squared to the third, that would be x to the sixth, right? We multiply those powers. So right here, I've got to sort of distribute. So I've got 3 to the 4x plus 6. I'm going to leave everything else alone for right now. Okay. Now I've got 3 to the 4x plus 6 times 3 to the x plus 2. I'm multiplying those two things together. What do I do when I'm multiplying two things together? What do I do with their exponents? I'm adding them. So like if I have x squared times x to the third, that's going to give me x to the fifth. I'm just adding those two exponents together, right? So what I want to do here is I'm going to have 3 to the, I'm going to do 4x plus x will give me 5x. And then 6 plus 2 will give me 8 over 3 to the 1/2. Okay, what do I do when I'm dividing? Like if I have x to the third over x to the second. Subtract, right? It's like x to the 3 minus 2, which gives me x to the first. So I am now subtracting. I've got 3 to the 5x plus 8 minus 1/2, right? And I've got to put that 8 and the minus 1/2 together. I would just go decimals on this one and do 3 to the 5x plus 7.5. You can do fractions if you want, but since it's such an easy fraction to turn to a decimal, I would just do 5x plus 7.5. And the question was asking us to have this in the form of 3 to the ax plus b. And we have that in that form, right? Our a is 5, our b is 7.5. So this is our answer here. So